Hello, everyone. Welcome back. Announcements. Please do not forget to submit your assignment. You still have some time to work on it. Remember, source code, class diagram, and a small document describing your solution, mainly your decisions in terms of the design that you implement. So assignment 4, you still have time. Source code should compile and run. Your class diagram should be a match to the source code. The source code that you submit, the diagram that you submit, they should be the same. Either you start working with one or with the other, but before you submit, review that they match. It's going to be a big part of your grade. So please review that. And your document, your decisions, you should check what you did. Now, moving forward, also for this week, I am asking you as a homework, please read the following papers. We're moving forward to software architecture. We're going to start with that today. Hopefully you already read the paper that I asked you to read the previous week about software architecture, Garland and Shaw. And after that, we're going to move forward to components, frameworks, and the relationship of that with patterns. And I am asking you to read before that this paper, Ralph Johnson. Can you tell me who is he? Why I am asking you to read a paper from that guy? I am sure that you know the name. So do you remember the name? Johnson, Ralph. Do you remember the Gang of Four? The design patterns that we review, 23 patterns that we review in the past weeks. One of the 4. Be right. So I am asking you to read his work connecting patterns, obviously, is part of the 4 authors of the book, but then frameworks and components. And we're going to talk about that in the following weeks. Not sure about the question. Global variable outside of the class, like what?
Hello, Professor.
Hello.
Yeah, so in the text file which you provided us in the slide, so outside the class on the top, so there are a couple of global variables declared. So I just want to ask whether it is we can expect in the text we can expect global variables outside the class.
For the input of the project, do you mean?
Yes, Professor.
Okay, no, probably was a typo or something, but no. Let's think like use like Java. Classes are the things that enclose methods and variables. What you can have is multiple classes in the same file, not one inside of the other, but in the same document, multiple classes that is valid, but no global variables outside of classes. Sorry for that.
Okay. Okay. Thank you, Professor.
Okay. Welcome. Okay. So reading, please, Johnson, this paper about component frameworks and patterns, homework number 1. Homework number 2, also, I am asking you to read another similar paper, a little bit newer, frameworks, patterns, and middleware. What is that? And the author is, well, one of the authors, this guy. A little bit harder, but do you recognize the name? Anyone? Well, there are 2 important books talking about patterns. Obviously, the most important is The Gang of Four, Johnson. The other author, the other book that is important, relevant, a classic, talking about patterns for architecture and for design. This guy is one of the authors. I am not asking you to read the full book. It's not enough the time, but I am asking you to read this one paper that, again, just like in the previous one, the paper was kind of the starting point for what later become a book. So 2 papers to read, a couple of pages. Hopefully you can do this reading this week. So we are going to start talking about that next lecture or probably next week. Good. So the papers are on Canvas. You can just get the PDF there and start your reading. Yeah, that one. Exactly. That is this guy. So both authors are well known in terms of software design. You will notice what they create. Moreover, I am sure that you notice when I ask you to read the paper about patterns, that the patterns in the book and the patterns described in the paper, they are not exactly the same. I am sure that you identify some patterns in the paper that didn't make it to the book, that are not part of these 23 of patterns. Anyway, something that we're going to review later. But you're reading, your programming assignment, so any question, please send an email. Now, moving forward, something that we reviewed previously, patterns. At least you know the name, the problem, the solution, the class diagram, and the source code, all of that, connected with these patterns in the circles. You know 3 in the creation, 2 in the behavior, and we review 4 in the structure, the ones that we have in the circles. You have the idea about what these patterns are about, how to use them. Moreover, what you are doing right now is try to take advantage of one or more of them to create a piece of software. And we're going to talk about your solutions and the better solution, or compare your solution to the best one later, but you know this. Now, the next step is the architecture. Let me be clear with this. When you are doing a piece of software, usually the first thing that we learn is coding. We learn a programming language, and with the programming language, we learn to solve some small problems. It's not a full list, but if you think about you as a programmer, when you learn to do coding, the big problems in which you take decisions are related with these 4 things. Which data structure are you going to use in case that your program is somehow handling data? The data is going to be linear or not? It's going to be a hierarchy, so you're going to move linked lists, trees, or you are going to go crazy with hash maps, sets. That is the first decision that you take in the programming level. Similar to that, recursion, whether or not you are going to use recursion to solve the problem, or you are going to keep using if and loops. Most of the things that you do when you create this, the algorithmic level, is the best combination of loops, whether or not we can say instead of 2 loops, 1 loop, playing with the variables or with a condition, or whether we need to replace 1 condition with 2, 3, 4, or split 1 method in several methods just because we do not want to have a cyclomatic complexity greater than 10. All these things that we review in the first weeks, all these things that you learn in your programming classes. The next level, up. And up, I need to talk about abstraction. This is really programming. If, loops, recursion, data structure, that is what you do. That is the core of the software. But when we're working with this, in some point, what we did is to move to the UML design. And moving to the UML design basically was all these things that we have done with the class diagrams. And when we talk about all these things that we have done with the class diagrams, is we introduce these ideas of composition, aggregation, or association, and obviously everything about inheritance. When we talk about composition, aggregation, association, the only thing that we was doing is to encapsulate something down. Composition, create a global variable. That global variable for the data, null or not, aggregation, composition. In the top of that, moving up with the abstraction, it's like, well, you know what? We do not want to talk about aggregation, composition, association, inheritance. It's like too complicated. We start talking about patterns. And in particular, we start talking about design patterns, the GOF patterns. And the only thing that we achieve is, in some point, for instance, we talk about observer, or we talk about singleton, or composition, factories. And the point that we reach in terms of the abstraction is that this work, every single one of them is a combination of these relationships, and therefore a combination of classes, variables, methods, which are enclosing some kind of source code. You mentioned one of the variables at the top, and that one helps you to move down with a particular UML diagram, and that helps you to move down with a particular source code. And some of the patterns have particular conditions, or some of the patterns have particular classes, or some of the patterns imply to use a particular data structure or not. Going up. What we need to do? Next step. One level up. The next level, architecture, software architecture. Software architecture, what we're going to review about architecture is able to use the patterns that we review in the same way that the patterns that we review are using the relationship that we reviewed before, in the same way that those relationships are connected with source code. One more level in abstraction, things that we're going to review are above that the GOF patterns. Why? One reason, timeline. We talk about this book, 93. Every single pattern that we review comes from 93, from the book. That one is just 4 years after we start talking about this object-oriented thinking. From classes to set of classes. In this time, what happened? The software become more complex. It was complex before. We create classes. Even with classes, we have a lot of classes. We need to review how to combine those classes. Okay, patterns. From here to here. 1 year. Garland and Cho, they have this idea, this concern about, you know what? Yeah, the classes, the patterns, the libraries, all these things are solving problems. However, there are more. And hopefully you have the opportunity to read the paper and to check what is the explanation that in this moment, Garland and Shaw present about why it's important to talk about software architecture and what is the profile of software architecture that they mention in the paper. We're going to talk about this, the paper that you read, the key ideas there. And just as a reference, I want you to think about it. The other paper that I am asking you to read, Johnson, continuation of this, he's involved in both, is just 3 years after we start talking about software architecture. On the one hand, you're going to have software architecture and all the things that we're going to mention. On the other hand, patterns, design, continue evolving. Here, if we talk about coding, the programming language that we use today are not the same that we use in this moment. This part is continue evolving. Patterns, they continue evolving. UML, continue evolving. All these levels continue growing independently of the other ones. It's not like one level of abstraction replaces the ones that are below. They exist independently, but they complement each other. So, software architecture. Key ideas with Garland, and hopefully my items match the things that you read. Yeah, complexity of the system. Good. So, complexity. We're talking about this idea of patterns and now this idea of architecture. And the key idea is the software is more complex. The software continue growing in complexity. Complexity. One of those elements for complexity, one of the things that imply complexity in software, size. And you notice that word, hopefully, in the paper with Garland. So the size increase. And talking about size, we're talking about lines of code. We're talking about size in that measure. More lines of code, more methods, more classes, more packages. Size. The problem is, if the size is bigger, we have something inside of that. We have more lines of code that represent condition, loops, data structures, recursion if you want. It doesn't matter. Bigger the software, bigger the complexity, for one reason or another. Complexity, size. One of the main problems that we identified before is the organization of the elements. We have this big number of lines of code. You have this big number of whatever item you have. And the problem that you need to solve always first is how do we organize those items? How do we organize in the software the lines of codes or the methods or the classes or whatever? And when we talk about organization, we're talking about items and relationships. And when we talk about items and relationships, we're talking about design. One first step to organize the size of the software, one first step was the design patterns. Design patterns, how to connect things. We already reviewed it. According with Garland, you know what? That is not enough. The design, considering the size of the software, is a good first step. It do not solve the problem. We need to organize these items. Okay, so we have these items and the relationship, yes. But a collection of those items solving a similar responsibility or related concerns? Can we encapsulate them as one entity? Do you remember? We have methods and connection between methods, and we encapsulate them in classes together with the common variables that those methods were handling. Now, we have a collection of classes, connected, related. Can we encapsulate that collection of classes with their relationships in one entity? And obviously now we can be concerned about the connection between the entities that are not related, that do not have classes or relationships that are solving one particular problem. And that is what is going to become the architecture. The architecture is not about the classes. It's not about the methods. What we're going to do, what Garland proposed, is in every single system, we can identify collection of classes and the relationships that one way or another are solving a particular feature. And what we need to think about is how we're going to connect this group A with this group B. The connection case. These groups, those elements, are going to be our new items, and the relationship between them are going to be the architectural relationship that we need to review. Design, the items, classes, the relationships, the ones that we already reviewed, composition, aggregation, inheritance, and so on. In the architectural level, the relationships are going to be different. The elements are this collection of the classes and their relationships. New things, new elements. The point for Garland, I want to be sure that you read that part, and hopefully you agree with that part. The important part with the software, as a programmer, the best decision that you need to take, your main responsibility, is to select a good data structure. As a programmer, your responsibilities are choosing in this context. Probably one of the most important, according with Garland, the data structure, I could open this and say, well, either condition, loops, recursion or not, and data structure are your concern as a programmer. When you move up, probably to the business level, the important thing there is the organization that you're going to select for the system, or the patterns that you're going to use as the designers. In each of the levels, those decisions are going to impact the level down. We're going to be sure to see that with your source code, don't worry. Anyway, organization. What we have today, what you are doing with your software, and hopefully you are aware, is something like this. Never, 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 as a developer, you are going to create a piece of software starting from scratch. Even in the software that you are doing right now for this class, or even in the projects that you did when you learned to do programming, you do not create software working with the Java virtual machine directly. Always, you are using libraries. You are using software that someone else created. You are using classes and relationship between those classes that are in some other place. In all the assignment for this class, there is some place called swing, Java x.swing. That is the name that we're going to put to this rectangle. And inside of that rectangle, you have these classes, panel, frame, widgets, a lot of classes. And those classes are one way or another connected. Inside there are inheritance, composition, aggregation, whatever. What you are doing, for instance, in your project, is this piece of software in which you're going to have one or two classes, whatever, your project. And you're going to have a connection or more between your project and this something called swing. And if you think about it, when you are going to do a piece of software, one of the first things that you think about is which libraries can I use? My software is going to be graphics. Which libraries do I have to do graphics? Graphical user interfaces. Are you going to do something related with machine learning? Which libraries do I have for machine learning? It should be Java, or could I connect with another language? Are you going to do some distributed computing system? Which libraries do I have? And hopefully some of these libraries that I put there ring the bell. Hopefully you're familiar with at least one of them. My point is, you could be working with Java. Your platform for execution could be the Java virtual machine. And below that, the operating system of the computer and the hardware. But never, 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 not for CSI110, you start programming from scratch. At least one thing here, the API of Java. Because by the way, Java is the programming language, yes, but it's also this set of libraries that you use to create your software, right? We review some patterns, design patterns that are inside of those libraries. Listeners are observers. Composite for the widgets. There are more. But now the next question is the connection between this one and maybe others at the same level, libraries, and the most important, with the software that I am going to develop. For the paper, a system with subsystems. Probably not the best concept. Today, this is a 94, remember? So system, your program, subsystems, the boxes. Today, we have several different names for this subsystem. Do you remember any name for that subsystem today? Maybe one important that is common in the last 10 years. Do you remember that one? Yeah, components. The paper is 94. I put this for you to remember what you read. Subsystems and systems. Today, we talk more about components. Instead of using these subsystems, sub-modules, or even modules, a core idea now for this one or for this one or the others, we talk about software components. Moreover, today, when we talk about reuse, taking a piece of software from one system and reuse that piece of software in a different system, we're talking about reusing components. We're not talking about reusing one class. We're talking about reusing a set of classes with a set of relationships. Because usually one class alone do not provide enough functionality. Usually the problem that we want to solve is not use one class, but a collection of classes. Think about this. If you want to use some kind of machine learning in your software, if I ask you to do a program in Java and that program somehow involved some pattern recognition. Create a program, and that program is going to read an image and it's going to tell me how many cats or dogs are in the image. Create a program, and that program is going to allow me to draw something on the screen, and the program is going to tell me if that one is a character, a number, or a letter. If I ask you to do something like that, obviously you're going to use probably Java Swing to create the graphical user interface to deal with the menus and the frames and so on. But in order to do the recognition of the item, the cats, the dogs, or these numbers, you're going to start thinking, there is some component that I can reuse here. Someone else already did some piece of software in Java or whatever other language with a wrapper in Java that I can connect with my software, and that piece of software can help me to solve this pattern recognition problem. And obviously you're going to find something, probably this one. And what you're going to do is start checking how to connect that piece of software, that component, that library with your software. You're going to learn the library. To be clear, when you learn a library, what you are learning is these connections. Should I need to create an object from a particular class in the library? After I create that object, should I call a particular method? Or do I need to implement inheritance for another class? Oh, the parameter for this method should be an object that I need to create, but this implementing a particular interface from the library. Relationships, association, composition, inheritance, because you want to connect your component, your software, with another one. Good news, there are also patterns for that. There are particular ways to do that. When you learn one library, it's easy to learn another one and another one, because what you found is there is a standard way to do these connections. Knowing the standards help me to use one library or another. Doesn't matter what is the domain, graphics, machine learning, whatever, because the connections are standards. But things that we need to review and probably work with this. Anyway, reuse of components itself. So what I want you to have in mind is the definition of the following concepts. Right now, we just mentioned components. The definition for you. But before components, we already talk and define instruction, statement, function, method, structure, class, model, packages. What if I ask you in your final exam to help me with the difference between these concepts? Do we understand the difference between instruction and a statement, for instance? What is an instruction? What is a statement? There is any difference between them or not? This is from your Programming 101, CSI 110. There is one difference. Can you tell me one example of instruction in Java and one example of a statement in Java? I am going to start with that. Instruction is a direction to do something. Yes, instruction is like a command, do something. Example in Java. Yeah. I am going to reuse that one from the chat, A++. I can use also the new, something equal new constructor, whatever. Statement. What is a statement in Java? Do you remember examples? In particular, I think in CSI 110 or in your Programming 101, you review two particular kind of statements in Java. Do you remember conditional statements? Or do you remember these loop statements? Well, those are operators, the limiter, the semicolon, the operator, equal. Those are or could be part of expressions. Expressions can be instructions, right? Statement. One example of a statement, and hopefully you agree with me, is the if statement. Remember, that is the name, if statement. Yes, that is a key idea. What is the main difference between a statement and instruction? The statement have instructions inside. Yes or no? If statement. Okay, it's a condition. Yeah, but that one have instructions inside. Statement, instruction. That's the instructions that you mentioned to me. A++, the new, whatever. The instruction is the last element if you think about a hierarchy. If you think about a tree, the last level are the instructions, but instructions can be inside of statements, right? Instructions can be expressions, those things that have variables and operators. Operators, they are always inside of an expression. Operators, they can be relational, arithmetic, or logic, 3 categories of operators. So if you think about the concept is operators plus variables, expressions. Expressions are instructions, can be instructions. Instructions can be inside of a method or inside of a statement. Statements are inside of methods. Methods and functions are the same. We talked about it before. One small difference, right? Both functions and methods have inside statements and instructions. Functions and methods. Methods are inside of classes or should be inside of classes. Functions, they are used part of the program. Remember? When we move from object-oriented, structural, that was the difference. But they both have inside instructions or statements or both. Then we move to classes. Classes have inside the method. What is the difference between a struct, and a class? Model. Yeah, that is correct. That is the definition. Two different names, but the names are different not because what they do or what they have inside, but because of the paradigm. Yes, basically the name that you use represent in which paradigm we are working. So if we mention methods, basically what we expect is that next we're going to mention classes. If we mention functions, that means that basically next what we're going to mention is maybe a model, a collection of functions, but those functions are not part of classes. We're outside of the object-oriented. So it's just the context. But inside, both have instructions and a statement. So that is models. Models, this connection of functions that I mentioned, classes, this collection of methods, again, the same. Structure used for C, C++, you remember in C you have this struct, collection of variables without the method, at least not in the original C. Later you can do things, but structures, classes, models, collections of the previous ones. We move to packages, particularly with Java. In Java, we talk about this collection of classes that create a package. I need to be clear. One package could be a component, one package. But usually when we talk about components, we are talking about a collection of packages that are also a collection of classes. But again, worst case scenario, if we told you about a collection of classes can be a component, well, it's going to be a very simple component, but it could be because a collection of classes have a package by default, at least with Java. So a collection of classes is one package, a very simple idea, but could be a component. So component is the last item that basically encloses all the things that we have before. Inside of a component, you have a package. Inside of the package, you have at least one class. Inside of the class, you have at least one method. Inside of this one method, you're going to have at least one instruction or statement. So that is going to enclose what you have. If we're talking about object-oriented, if we're talking about structural, well, it's not going to be about packages. It's not going to be about classes, but it's going to be maybe about, I have a component. This component is one module. That module have a collection of functions. The good news about component is that it is not connected only with object-oriented programming. It's just something that encloses a collection of functionality in object-oriented with the object-oriented elements, in structural with the structural elements. It's a component, is solving a particular problem. And the best idea is to have reuse of components. At least that is the plan with Garland. We need to reuse not these things that is copy-paste, or these things copy-paste also. This one is more or less reuse, This one could be great. We need to review things, how. But please check the concepts, the different definitions, and be sure that you identify what is the meaning for each of them. Could be a question in your exam. Moving forward. Yeah, help me with that question, the difference between module and class. What is a module? Two important things. Number one, if we talk about a module, usually we're talking about the structural programming, not in object-oriented. Usually in object-oriented, we're going to move from classes to packages to components. Usually, we're not going to talk about modules. The closest thing to a module, and we reviewed quickly this before, could be the idea today of a package. Today, 2020, if we talk about a module and we try to match the module with object-oriented, the closest level could be module is a package. We reviewed this before in the context of 97, the papers that we read. In that moment, what they call it a module become this idea of class. Remember, in the 70s, in the 60s, this idea of one module, this collection of methods with the variables, become a class. They evolve. Today, the closest thing to a module in a structural to object-oriented could be a package. Not one class, but a set of classes. Still, it's a group of methods and variables, but instead of just methods and variables all together in one space, in one box, it's a group of methods and variables organized in classes, like in small boxes, and then they together in a big box. And the name for the big box today is this package, and therefore module. So the difference is because we're talking about 40 years. So the size of the software is kind of a little bit bigger today. So we move module in structural to package instead of class. Good? Okay. So relationships. I just want to be sure that we agree with this. Relationships with the structural, with all the things that we reviewed before, the only relationship that we have is, number one, sequential execution of instructions. the relationship is I am one instruction and I have instructions above and below, so sequence. Then we move to calls. One method call another method. So these two methods are related, are connected. There is a relationship between them, calling methods. And suddenly we jump to object-oriented and we have all of this. We start here. We jump to object-oriented and we get this. When I mention jump to object-oriented and get this, we still have the previous one, right? So all these relationships exist in any of the programs that you are doing. All these relationships exist in object-oriented. It just those ones exist also in structural. These are the new things with object-oriented. Now, all of this is in the programming level. Next. Yep, I agree with that. Usually when we think about components, modules, or even somehow packages, the key idea is a responsibility, a functionality, a service, a behavior, something that is not just about a group of instructions or a group of software elements, classes, and so on, but this thing here, whatever is inside, they together solve a problem and solve a problem for the user. That could be a key idea when we decide if something is a component or not, if something is a module or not, if something is a package or not. With the classes, we're thinking about this class solve a problem for the developer. I mean, this class here is going to be able to do something for moving forward the programming of this. But when we talk about the component, the module, the packages, okay, this guy is going to provide something for the final user. And hopefully it's clear the difference between doing something for the programmer and doing something for the user. Be valuable for the team that is doing the developing, or be valuable for the final user, the person that is paying for the software. We're going to do one homework about it, but yes, that is a good point. So, relationship with architectures. This is something that Garland talked about when we move forward from programming and design to architecture. Never before we considered this as a relationship. In particular, I want to talk about two. Protocol of communication. Yeah, you have this software system that is Canvas, but Canvas is running in one computer in some place in the cloud, and you want to use Canvas in your home, in your computer, and therefore you're going to use a piece of software, your browser. You want to connect those two pieces of software. You want to connect those two systems. The connection between them is not association, aggregation, composition, inheritance. They are two systems separate, two components, independent. You're going to connect them. The connection is a network connection. You're using internet. You need this software, your browser, to access another software, this Canvas. But this connection implies a lot of things. I mean, this idea of, yeah, we're going to use internet to access Canvas. That is a pretty simple explanation of what, as a software engineers, we need to do in order to complete Canvas and provide access to the students. And hopefully you know about it, but it's something that we're going to review. Two key ideas: protocols of communication, I am talking about network protocols. And the other is, what do you do in order to have access to this networking structure, to access these protocols and all the things involved in a programming language such as Java? What if I ask you to create a program in Java to connect directly to Canvas and replace the browser? Can we do that? And the answer is, yes, we can do it. What do we need? One particular element. Do you know which one? Well, let's assume that Canvas is the one that have the server. What we want is to connect to that server. If I ask you to do a software like that, I am sure that you're going to start searching for what I can do in Java to connect with a server, what I can do in Java to use the HTTP and HTTPS. Those are the protocols. Yeah. So what I can do in Java to use the network infrastructure and connect the server with the IP. Hopefully we have the IP. Yes, we need that. And use those protocols. And you know what? You're going to find that there is a component in Java, a component, a group of classes, a package, probably JavaNet. And that package has inside a lot of classes. One of them, a class socket. A package, a class. That class is related with others. But you locate the main one, and there is a class socket, and there is a friend of this one, both connected. Server socket is the one that I need if I want to be the server. For my scenario, what I want to be is the client. I want to connect with the server. And hopefully we identify these two roles, right? The server, they want to have the information, in this case is Canvas, and I want to be the client. I want to have access, just like your browser, but with an application that is different from the browser. But both classes exist in that package. The only thing that I need to do is to learn what kind of connection I can create between this component and my components, your software, your system. And that is going to have a name. And there are going to be particular things to do to use that relationship. We need to review, but client server, that is a name that I am sure ring the bell. That is something that you have listened before, client server. It's a pattern. Anyway, communication between network, which imply physical distribution. We're talking now about this software in which one part of the software is in one particular machine, you call it the server, and another part is going to be in a different machine, my laptop, maybe. It's not only that we're talking about bigger software systems, but we're talking also about different locations. And in some point, we're going to start talking about performance. And we're going to start facing different alternatives, not in the design of the software, but in the design of where to put the software, in which hardware, in order to achieve some qualities, including performance, when we talk about these network systems. And I am sure that you read this in the paper with Garman. It's only one of the patterns and only one of the problems that they mentioned there. Only one. There were more. Yes, a lot more. And hopefully you remember reading about this. I basically copy-paste the titles. And all the things that I mentioned in my previous slide is related with one of these guys. So you talk about one? Yeah, I talk about one, but the paper mentioned a lot more. I want to talk about some of this in a practical level. However, something that I expect you to do is to read the paper and understand all these problems. There is a reason because all of this exists. What I did just quickly is to describe the reason for one of these, the one with the red arrow. You need to understand the reason for the others. It's just part of the knowledge that you need to have as a software engineers. What happened? Why we moved from what we had before? I am an expert programmer. I am an expert in UML. Why that is not enough is kind of the background for this. Now, moving forward, in the same way that we have the design patterns, what we're going to have now for solving this kind of problem is architectural patterns. And as I mentioned before, the design patterns also call it the Gov patterns. These guys, what they give you is a class diagram. All of them have a class diagram. And therefore, because they have a class diagram, they are giving you somehow more or less code, source code. What we're going to review now architectural patterns. They are above in abstraction. This, what I put below and above is all about more or less abstraction level. These architectural patterns do not have a class diagram like the design patterns. We are not going to mention one of these names and they are not going to be equal to a class diagram. That is not what is going to happen. They are connected with one or more of the ideas that we mentioned before. They are connected with one or more design patterns, but they do not have a solution like one class diagram or a specific source code that explains to you how to implement the solution. So they are connected, but there is a difference there. No class diagram for architectural patterns. That is important for you to remember. Now, there is not going to be class diagram. No, what we're going to have, use a diagram with connections, but it's not UML. UML here, Unified Modeling Language. Here, we do not have that. Okay, what we're going to have, let's check. I want to review with you some of these patterns. The most important those three. If I need to select three patterns here for you to remember and be proficient with them, these three. In fact, hopefully you already know one of them. Probably the most important if you are doing programming with graphical user interfaces. One of these that you already know. Which one? From the three that I put in a circle. Better know as MVC, yeah. So I am pretty sure that you know that one. At least you know the name. Whether or not you have used that before or not is a different story. We can start with that one. And then we move to the others. Those three, the important ones, but you are getting a very good idea of the others, reading the paper. We're going to do a summary at the end. So these three patterns, architectural pattern. Question in your exam, can you mention three design patterns? That is one question. Can you mention three architectural patterns? That is a different question. Be careful. Design patterns, architectural patterns. Architectural patterns, this is the list. Design patterns, you have 23 in the first slide of the class today and before. So architectural patterns and model view controller, the full one. Very simple. Do you have a piece of software? You're going to develop software, and that software is going to have a graphical user interface. Notice the condition here to use model view controller is you are developing a piece of software, and that piece of software is going to have a graphical user interface. If you are going to have a graphical user interface, the recommendation from the architectural point of view, split your system in 3 elements. Just think about it. You're going to have this piece of software, the piece of software have graphical elements, create 3 boxes, and whatever you do is going to be inside of one of these 3 boxes. And the name for those boxes, for those spaces, is going to be the view, the model, and the controller. Okay, guys, this is very important. Thank you for asking. I have been receiving this question about, for the assignment, if you can take the input from a file. My answer is as follows. The behavior in your system should be the same that you have in a programming environment. So my understanding is if you have a file, when you read the file, the content of the file go to the editor. So when you click compile, the input for the compiler is from the editor, always. So open the file, go to the editor, click in compile, read the input from the editor. Now, if you are not using a file, if you are just starting a new file, for instance, you can directly be putting code into the editor, and therefore the compilation is going to happen in the same way. So my recommendation is following this. That is how your developer environment works. My advice is when you read a file, put the file in the editor, and just be sure that every time that you compile, you are compiling things from what you have in the text area or whatever you are using. And I think this will solve the problem. You do not need to have kind of different behaviors or different implementation for whether you want to read this directly or you want to read this. I mean, those two, there is no reason for having these 2 different options. If you can just put this here and always do the compilation directly from the editor. I don't know, I received that question a couple of times during the weekend, and thank you for asking right now. Hopefully this answer will help everyone. It's like you can read the file, put the file on the editor, and then compile from the editor. Make sense? Good? Okay, so moving forward. Going back to this. Think about the idea. The idea is pretty simple. You're going to do a piece of software like the assignment that we're doing right now. Separate views, controller, and model. Separate means the classes that correspond to the view, the classes that correspond to the controller, and the classes that correspond to the model. The question is, which classes should be in each of those boxes? Which classes are part of the model or part of the controller or part of the view? Answering the question in the chat, association is calling a method with probably a local variable. Composition or aggregation imply a global variable. So if you have a global variable inside of the class, that global variable immediately is going to be aggregation or composition. It's going to have a diamond involved. If there are not global variables, what you have is association. Probably that is the 2 main difference there. For your assignment, you have the diamond, but the only thing that I ask you to identify is aggregation, the white diamond. there is no composition, there is no dark diamond, because we do not have the new, remember? So because we do not have the new, the only thing that you can be sure is there is a global variable. If there is a global variable, global, I mean global inside of the class, I mean an attribute. So when you have attributes, immediately you're going to create an association, aggregation, the diamond connection. If not, if you have a local variable, you're going to create this association, the connection, that's it. There is no new like an instruction. You can, I mean, not new as an operator new. There is no new for creating objects. You can have an instruction new, like the one in the chat, like new parentheses. That is fine, but that do not represent the operator new to create new objects. In our language, we do not have that. Therefore, you do not need to worry about composition. We can have new as the name of an instruction. Even we can have new as the name of a class. I do not put any kind of limits to the names. So new can be the name of a method, the name of a class, an instruction, whatever, but it's not the operator new for creating objects. So no composition. Okay, good. So going back to the MVC, which classes in your assignments correspond to a view? Which classes in your assignment correspond to a controller? Which classes in your assignment correspond to the model? The easy one always is the view. Which classes should be or are the view? Anything that the user is going to solve is part of your view. And your examples are correct. All the widgets are views. Your menu, your frame. And obviously, I'm talking about the classes that inherit from that. If you have frame, is the library, but you have one class that is inheriting from frame. That class, main or whatever name you use, is part of your view. All these classes that inherit from panels, if you create a left panel or a console panel or whatever, all those classes that inherit from the panels, they are part of your view, and so on. Obviously, you have here Swing, the package, and that package is connected with a group of classes in your system. All those classes connected, related with Swing, they are part of your view. So it's a simple way to identify which elements in your system are your view. All these elements that are related with showing something to the user, all these elements that are related with visualizing something. Or if you want to think as a programmer, all these elements that one way or another for your assignments are related with this library, call it Swing. That is easy, right? Now, what is the model? I have a question regarding your midterms. My understanding is that your midterms are already graded, so not sure if they are available on Canvas or not. Something that you would like to do is to contact the TA in case you haven't had access to your grade. But my understanding is that they were graded during the weekend or Friday or something. I don't know. I mean, I can check with the TA or you can check with the TA directly. But my understanding is that your midterms are done or almost done. Okay, they are not graded. Okay. But if they are not graded, I can check with the TA and ask the TA to let you know what is happening. Please ask me again in the next lecture, so maybe I could have more information about it if you do not receive an email with your grades before that. Okay, so going back to the model. The model. Yeah. Everything that you have that is something that your software do, anything that you have that is related with solving the problem. Solving the problem in your assignment, for instance, the problem that you're solving is reading a file, compiling the file, somehow read the input, create results, anything that is related with that, solving the problem, the functionality, your requirements, obviously, except the visualization of things that we already talked about it, but every single thing that you have that is about solving the problem, and most of the time here, we are talking about all your data structures, everything that you have to handle data, process data, all that is part of what we call the model. The model, it could be a package, as we described before. It's a collection of classes. It could be more than one package because the classes can be organized in several packages. But this box, this space of classes that are solving the problem, we call it the model. Everything except the views. Everything except the things that are connected with string. Okay, solving the problem, showing the solutions. What about the controller? The controller is a fancy name for something that we reviewed before. The one that connect the model with, yeah. The controller, one of the things that it's going to do is to connect the view with the model. Let me be clear. It's going to connect the view with the model in this direction. The view with the model. But then the model can be connected in this direction. And that creates a loop. I need to talk about the connections more, but just think about this. Tell me, starting in the view, what are the things that call the models? What are the things that somehow start in the view, but end in requesting a functionality? In Java, that is the thing, right? In Java, you use listeners. The listeners are the ones that connect your graphical user elements with the things that solve the problem. According with the model view controller, your listeners should be one element in your architecture. Question: are you using model view controller in your assignment? Did you use model view controller in your previous assignments? And the answer, you know what, is yes and no. I am sure that all of you in your assignments in which there are graphical elements involved, you can identify a view. The question is, do you have a method or an instruction that is related with functionality inside of any of the classes that have some visualization thing? Do you have instructions for solving a problem inside of one of the classes that inherit from panel? Do you have some kind of functionality in the class that inherit from JFrame? If the answer is yes, something is missing here because you are not split the view from the model. There is a reason because we need to separate that. If we separate the view from the model, we can change the view without getting concerned about the model. We can change what the user saw without changing the functionality of the system. Think about it and review. By any chance, do you have these two mixed? By any chance, do you have one class that you cannot identify if it should be here or here because the class seems to belong to both, have functionality, but also have graphics? If you have that scenario, something is wrong, we need to fix it. Now, the worst case scenario, something that we need to review in detail. How many of you have your listeners separate from your views? Common practice, guys. We put together the listeners and the views. We put together the views and the controller, because that is the way in which you learn programming, graphical user interfaces in Java. You learn to have these two together. Remember, the same class that do the extend JFrame is the same one that is implementing the listener. However, the fact that we learn to do that in a programming 101 class, that doesn't mean that it's the correct thing to do. According with model view controller, these two things should be separate. Are you asking me to have one class with my extend JFrame and a different class with my implement action listener? In a big system, yes. Remember, everything that we reviewed today is about big systems. We're going to continue with that in the next lecture. I am going to show you source code for this. Good? So any question, guys? Okay, see you next lecture.